Okay, today's topic is our ultrasonic flow meter, which we call ZM Ultra Mobile. It's a mobile device, very robust and portable, mobile, for very long measurement periods in the field. So it's designed for very, very long stand-alone alone times. And it's for filled pipes, for fresh water. You can also use it for raw water as well, doesn't matter, but it needs to be a filled pipe. And we measure usually with clamp-on sensor, so it's non-intrusive measurement. So you just have the sensor pair attached to the surface of the pipe and you can start immediately the measurements. All right, to go a little bit into the key features of the device. It's very robust. You see it on the case. I will turn on my laser pointer again to just have it followed. Now we are. So you see the case, it's very heavy duty. It's a PE shockproof casing with IP67 waterproof tightness, 68 actually, 68 if the lid is closed. If the lid is open, you have IP67. With all the ports on the back, it has a battery compartment which contains 2 batteries for very long standalone times without recharging. Like I said, it's flood-proof or waterproof, IP68 if the lid is closed. You have direct diagnosis and signal analysis in the device. So if you are already a little bit expert of ultrasonic flow measurement, you can look into the details and you see if you're really doing a good measurement or not. We have the opportunity, so we have 2 versions. One is with GPRS, one is without, so we can remotely transmit data. We have the possibility to attach 2 additional analog sensors, for example, temperature, pressure sensor, level probe, to the device, so it also works as a data logger. We have different digital and analog outputs too. So you can transfer this data or signal from the ZM Ultra Mobile to an existing data logger if you already installed some in place. Okay, so about the measurement principle. So we are measuring always on filled pipes, full filled pipes. As soon as there is air inside the water or on the top, the measurement won't be accurate. But usually the fresh water pipes should be without air. So that's also the reason why you install lots of air wells. And air always causes hydraulic problems in water infrastructure. Therefore, this is specially designed for fully filled pipes. So we can measure with the ZM Ultra Mobile 1 or 2 measurement paths. That means, like shown in this picture here, we can have 2 pairs of sensors installed on the same pipe to have a very accurate flow reading. This is in order to reduce the influence of any turbulence or spin inside the water column when it's flowing. I told you already in the previous webinars that we need 5 times the dimension of the pipe before the installation of the sensors. So after the flow or inflow direction, 5 times D, and 3 times D, the dimension after the installation of the sensors, in order to eliminate turbulence factors in the flow. Okay, We also have the possibility not only to measure with so-called clamp-on sensors, but also with insertion type of sensors. The clamp-on sensors, they rely on a really exact parameter settings of the pipe material and the wall thickness of the pipe. If this information is not correct, you won't get good readings or even accurate readings. And to eliminate this factor of pipe wall, we have the possibility to insert the insertion type flow meter sensor, and they need to be directly in the water column. It's the same measurement principle. It's also ultrasonic signal transit time, but with the insertion type of sensor, you reduce this influence of the pipe material. If this is unknown, or you just don't, for example, get a good signal because of whatever reason, maybe the pipe wall is not homogeneous or something, then it's always the best option to insert the insertion probes. Of course, you always have the opportunity to attach additional sensors. Like I said, here it's displayed our pressure sensor, but also level sensors or temperature sensors you can attach. You just use the analog inputs to the device and use it as a data logger in conjunction. How the transit time measurement works, this is quite simple. So you have two sensors, one pair, and the two sensors communicate with each other. So one sensor sends out a signal, the other one then receives this signal, and then it goes reverse. This sensor sends out a signal, this sensor receives the signal, and what happens if there is a flow inside the water column, inside the water, the signal which travels together with the flow is much quicker, not much, but it's a fraction. We're talking here about nanoseconds. With correlation, we are in milliseconds, which is a 1,000th of a second. Nanosecond is 1 billion of a second. So you have millisecond, microseconds, nanoseconds. So it's a very, very small difference of the time the signal travels with the flow than against the flow. But with this very accurate measurement, we can distinguish the nanoseconds area. So it's very, very accurate. It's like our correlator measures in milliseconds. With this device, I'm 1 million times more quick in taking readings, let's say. Okay, yeah, you always have a certain angle the signal is transmitted into water. This is due to the surface change of the material and the water. So these are factors you cannot influence, and therefore the device always needs to know the exact pipe material and the thickness of the material. Otherwise, it won't give you a really accurate reading. So the applications of this device, of course, I name it here in the first place, is leak detection. We want to know the flow, for example, in different zones, area of our water network. And the most important factor here is the minimum night flow we can compare. And with this factor, we know how much water we are losing in different areas. What we also can do is pump verification. If the throughput through a pump is still like the specified parameters from the manufacturer, or if there's a problem with the pump, the sealings, or something else, or even the engine, the driver. It also can, of course, work together with the data. You can analyze the behavior of your users, of the customers. This is a very important and already well-known application of data in any kind of infrastructure or electricity. This is since very long already in the statistics. Okay, you can also measure, of course, the intakes and outlets of cooling water or circulation systems. So it's not only for fresh water, for water supply, but we also installed it on, for example, heating pipelines, even cooling pipelines. I already mentioned once we have a project in Dubai where we'll apply also quite some numbers of these units. So yeah, this is not limited to the freshwater application. Also, for example, refineries, any other liquid, it's just needed that it's a filled pipe, no air inside, and then you can. Okay, of course, we also can monitor processed water, surface water. We also install it temporarily, so it's a mobile device. We put it on different section where we assume we're losing water, and you can really take it in a measurement campaign for water loss reduction, for leak detection. So this is balancing the water amount you're losing, which is very important, especially for the economics and companies. They don't want to know the amount of leakage they fix every week. They want to see how much water loss reduction they could achieve. And therefore, it's always a good idea to first measure the flow in order to fix the biggest leaks in the first run, which of course cost the most of the money. Okay, the strengths or unique selling points, I would call them already here. We have a very robust case with IP68. With open housing, still can have IP67. We have electronics in the separately protected area. We can also manufacture this device as an X-proof for any application. So this has certification for explosive areas too. We have very large batteries inside which can measure more than 1 year with one battery cycle. Yes, that's all for this presentation. There we continue with the unique selling point. I already mentioned extremely long battery life designed for long-term operation. We have 2 batteries, so you always have the opportunity to charge one battery in your office. When you see the battery of the other one through the remote data, if you transmit it through GPRS, gets low, you take the new fully charged, you put it inside, remove the discharged battery, and you don't need to do a restart the device. It just continuously operates, so it's very convenient for the daily operation. You can also, of course, supply, if you are, for example, measuring in a tank where you have power supply, you can measure, you can take the power, of course, also from the infrastructure there and connect it to the device. This I already explained. We will also see it in real. What we also did in the past, which is a good idea to have, is we can also operate it by solar panels. So it is only using the internal batteries as buffer, and the main power supply comes directly from the solar panel. So this is also quite convenient to use. So on the back, sensor connectors. You see here, this one is grayed out. This is, no, it's not. This is V1, the input for sensor pair. This is for sensor pair. The multi-IO sockets, input-output socket. There you also connect your power supply if you have. You can have the different sensors if you want to monitor different parameters like level or temperature, pressure, whatever. And here you have the connection for the GPRS external antenna. This is an overview of all the digital input outputs. Like I already described, we have two analog inputs, active or passive, so 4 to 20 milliamperes. One analog input passive, this is only a passive input. One analog output, so it gives you the reading from the transducer. One digital output, for example, impulse reader, and another digital input and a digital output. So connectivity, the device, this is very genius solved and developed, I would say, can operate with any Wi-Fi enabled device. So you don't need to have a special software or loggers, for example, where you download the A.S.T OAD from the Google Play Store, or the SATEM Ultra Mobile. You just connect your Wi-Fi enabled device with the Wi-Fi, which comes from the SATEM Ultra Mobile. So it works or operates as a router, and you access an internet browser, and with the internet browser, you can directly go into the settings of the device. I will show that later on in our live demonstration. Okay, yes, you also see directly on your display and the flow. You can do the settings. You can download data from the device on your Wi-Fi enabled device, or just put it on a USB key, which you can also connect to the USB port, which is inside of the SATEM Ultra Mobile. You can also, of course, transmit data from your device through email or Bluetooth necessary. Of course, this is the main function and a very good feature, the remote data transmission. Of course, this costs a little bit more than the standard version because this has a modem inside, and you need a SIM card also to operate these functions in a local network in the specific countries. Yes, we have worldwide connectivity. We have a modem for each region. Just contact us and we will figure out what's the best opportunity for you. Okay, this is what I just described earlier, the compatibility. It's independent of any operating system. So before we got the question if we also want to develop the A.S.T OAD app for Android, for iOS, for Apple devices. This is planned, but at the moment we're trying to add more functions to the Android versions. So with the SATEM Ultra Mobile, because this is independent of it, we can operate on all kinds of operating systems. Okay, just some examples of some applications. You see here very large pipes, and this is the most difficult cases to measure on. So you see here 1,800 millimeter pipes, even 2,200 we already measured, and you still have a very good and accurate flow reading here, and the signal is excellent. This is an example, again, taken flow was in the pipe 6.5 cubic meters per second, so really large and very important to monitor this kind of pipes. Such a pipe bursts, we don't want to know what might happen there. I have with me the tablet to show you the readings. I open the device. You see here the USB port where you can extend the memory of the device. So you can always put the USB key inside, and then you have, of course, these few gigabyte more on memory. The built-in memory is good for up to 1.5 years of reading in a 5-minute measurement cycle. So quite yeah, a lot of data which can be stored inside the built-in memory. Okay, here we have the battery compartment. I have here next to me the batteries. This is the charger to charge the batteries. So as soon as you put in a battery, you will see here the LEDs turns on. So after it boots, it will start the Wi-Fi. And I just close the lid here. I turn on my tablet. You always close the lid, that's fine. I will start my tablet. Then you need to go, of course, into the settings and you go on the Wi-Fi. Now I'm connected with the Wi-Fi of our building. I want to search for the Wi-Fi of the ZM Ultra Mobile, which is then the number shown here. Now it's connecting. I already connected the ZM Ultra Mobile one with the Wi-Fi with this tablet. But if you do it the first time, you need to type in this Wi-Fi password or PUC, we call it. The SSID is the name of the device and shown then in the Wi-Fi, and you just look for this kind of connection. Okay, when you connect it, you will also see the Wi-Fi icon on it on our tablet. Okay, if you have connected to the Wi-Fi, you only start your browser. Here it's the Android browser standard version, and then you just connect through an IP address, which is always the same. You can find this in the instruction manual. I already have it inside here. It's 192.168.1.1, and you click on go, and it will immediately start to connect to the device. Now you get the message here already. Error VPath number 1 is not connected, not communicating. Of course, I have not attached yet a sensor, so it won't be able to take any readings of the device. Okay, now I'm already in the main window. If I would have connected and set up a measurement place, I would immediately see the readings. So the flow, here the level, if a level sensor is connected, the flow velocity, which is related, of course, with the flow. The temperature is actually a very interesting factor. It's not the measured temperature, but it's a calculated temperature. And it's just a value for you to check if the installation of the sensor was done correctly or not. If the temperature deviates more than 5 degrees from the real water temperature, so you can measure that on place, or you just estimate it. If it's more than that, if, for example, 10 degrees, you will feel very heavily. If it's 10 degrees or 20 degrees, the pipe and the water. then you need to readjust the sensor alignment. Okay, this is the totalizer to see how much water already went through this measurement site. Okay, then you have here the main window with all the icons you can access. To program a new measurement site, you always have two options. One is going into the application. The other option is going through the quick start to put in the parameters. And this means I get guided in the quick start from step 1 till 7 to set up the parameters. In the application, I have kind of the same functions, but I don't get from step 1 to 7. I always need to do that like manually. In the data section, I will do the setting up later on, so I go just quickly through the rest of the menu. In the data section, you can see directly the data which was recorded. I see here you can see the data what was just recently taken. Now no sensor was connected in the last hour. I don't have a reading, but before I tested if the device is operating well, I have some data 3 hours back. Yes, then the day totals. This is the value you also see in the first icon. You can also reset that, but not in this menu. It's in another menu to balance the totalizer. Data storage for downloading the data onto a USB stick, for example, if you have connected it to the USB port, download directly to your tablet. You have the opportunity to download as CSV or TXT file. CSV is Excel, TXT is a normal Word. Then you have here the option to choose what is the data depth. That means like how much data you want to transfer. Standard is, of course, the flow, flow velocity, the temperature, the level, all the parameters you have seen before in the main screen. Extended means you're also transmitting some diagnostic parameters. In the expert mode, you transmit all the diagnosis signals, so you can really say later on if the measurement which was taken on the place was a good measurement or not. And the last option is only the day totals, which is very, very small amount of data. Okay, you can delete, you can load parameters, you can save parameters, you can even compress the data, so you get a zip file. Yeah, that's in the data section. I go back in the system menu. You have here the information on the device. So you see the serial number, article number, some MAC address of the processor, the firmware version, the bootloader version, which is inside the Wi-Fi. So the kind of the router which is built inside. When it was built, when last time I did the update of parameters, settings, then the battery value, the voltage, you see here nicely displayed what it is in percentage. So it's almost fully charged with one battery attached to it. Then region settings, of course, here you have the opportunity of setting the languages. Again, we have many different languages. If you don't find it in the menu, just contact us and we can also help you with other languages. Then the format of the date. This is the German format. This is the English format. You can choose already here the units metric, which we use here in Germany or Europe. Then, of course, you have the imperial measurements or units, and also the data units. So this is the display, and the data is what is stored on the memory. Time and date is clear. Okay. Error messages if something was not correct. You see it here in the display. VPass communication is not okay. No connection. Of course, I don't have connected our sensor yet. Then in the service, you are able to access the service level. This is just to do some additional programming to also, for example, for the GPRS modem to unlock the modem and the function of FTP transmitting the data. I have here reboot and power down. That is for resetting the device and just make a reboot. Power down, this is required if you want to switch the device off. You either need to take out the batteries of the device, or you need to go through that menu. Otherwise, the device will always stay turned on, and it will take measurements. Okay, parameter reset is clear. Feature unlock is for GPS. Then updates and update bootloaders. Of course, if you have a new firmware version, you can do that. Then here, the storage mode. This is important. Again, you have here the different options available. Normally, we operate in cycle mode. Cycle mode means it's always sleeping between two measurements. And in the cycle mode, I have only the option of a minimum of 1 minute cycle. That's the minimum resolution or maximum resolution you can get. In the continuous operation, you can go down until 5 seconds. So that means every 5 seconds, it will store one value. Of course, it will take much more readings, but the value which is stored is only every 5 seconds. And it won't sleep in between the cycle. So this is clear. And here you see now the new total. If you want to reset the totalizer, you just type in here 0, then the totalizer is back on 0. This is for the systems menu. Then communication, here the Wi-Fi, clear. You can just choose another password. For that, of course, the old one is required, which is usually printed on the label inside our SATEM Ultra Mobile. And GPRS, I now have with me a unit without GPRS. If I would have one, I could enable here the GPRS modem for transmitting the data remotely. You see here already the options through FTP, through email. We have different options to transmit the data from the GPRS of the device. Okay, display. This is just the windows you have seen in the main screen. You can choose a different setup. If you like battery, this is a little bit, I always complain to development why they did it like this. You see here only the battery voltage. In the service level or in the service system menu, you have the same, and it's just much more nicer displayed. So here you have also a percentage of the battery status. So it's just useless, I would say. Quick start, I will go into that later. And alert is if I want to put thresholds to send out an alarm in case of abnormality of the flow, of the velocity, temperature, battery status, of course, or if I use a digital input from external sensor, I also can use this. Okay, Then the two main windows is Quick Start and Application. I will now go through with you in the Quick Start. I will be asked if I want to create a new measurement place. I don't want to mess up with the data I have put in from our place where we will connect the sensor in a minute. So I click here on No. It still goes into the menu, but it will show me all the settings I have done before. If I click on yes, all the settings will be deleted and I need to type them in additionally. So here I'm asked about what language, the date of format of the date. I want to have the units displayed in the display here, the units stored on the data, system time, time zone. Now I can synchronize time and date with the time from the tablet. And now here, this is important again, continuous operation. Event mode, I didn't explain that actually. Event mode means I can also enter in event type. So of course, often it's the flow and I say, please record only data when the flow is exceeding or dropping below a certain value. I type in here. Also in the event control mode is the same. So you can also control the measurement by these values. And cycle mode is in the battery saving operation. Okay, in the next window, you always click here on this small icon on the top. You have the measurement place. This is the most important sections. Normally, the device detects automatically what type of sensors are connected, usually always with clamp-on sensor. In some cases also you can, or we're measuring with insertion types. Then the path setup. If you want to, we have three options. Diametral, only one path means the signal travels only one time through the medium. V means the signal travels 2 times through the medium, and diametral in the W mode, the signal travels 4 times through the medium, means getting reflected on the bottom, back to the top, reflected there, on the bottom, reflected, and back to the next sensor. Okay. Then the path number. This is not the same with the path setup. So you also have here the 1 path, 2 path, 4 path. But this one is if you attach a second pair of sensors on the same pipe to have a more accurate flow reading, you can set that here. So more than 2 is not possible because we only have 1 inputs of the sensors. Then you have the medium, what you want to have. Of course, this is needed in order to get the right sound velocity of the medium of the liquid you are measuring on. Then the assumed temperature of the medium, we assume we have about 10 degrees, 14 degrees, something like this. Then here the channel profile or the pipe profile, we have also the opportunity to measure on rectangle, for example, on sewage pipes, also possible. But then we need different kind of sensors. 99% of the application, of course, we have the water is with pipe, with pipelines in a round shape. Okay, here you can type in the pipe wall thicknesses, the circumference of the pipe, and the diameter, the dimension of it. So you only need to have, in this case, I have 2 pipe materials. I have an outer layer, which is out of ductile cast, and a lining, which is made out of concrete. So here I would need to type in 3 parameters in order to calculate the other 2. If you only have 1 material, you just type in 2 parameters and the program will calculate the other 2 parameters. Save the parameters, yes. I didn't change anything, but still I will. Now you see here in the quick start menu, you have the sensor alignment. If I go outside and connect the sensors, you will see that. I will do that in a second. Here you see the distance, the spacing of the sensors from the edge to the edge of the sensors. The path length, that means how long the signal will travel through the medium. And then here, the percentage of signal received from each sensor when it works as a receiver. So it's receiver, it sends and receives signal at the same time. Then you can here go with the analog inputs if you want to activate them. Analog input 3, input 2, input 3, digital input, and then you are done. I don't have any additional sensor with me, so I leave this. Okay, this is the quick start for just getting you guided through it. We also have the same opportunity to do with the application, but you have more functions here. On the measurement place, you have the same settings I had in the quick start. You see here, but I also have here some more functionality. I can set a damping and stability factor. Standard factory set is 30 seconds, so it always will have a very, very how to say, short reaction time. If I put in only 1 second, so every 1 second it will calculate a new flow reading. If I have 30 seconds, for example, it will take the average of the past 30 seconds, so it's a gliding average, and therefore the flow will not fluctuate so much. In order to get a very nice flat curve, the damping and stability is the factor to influence this. Okay, on the V path, I have the opportunity to see my sensor alignments and also the area where I install my sensors. The inputs outputs is the same in the quick start. You can enable them, and now important is here the diagnostics. This is maybe for really experts and professionals. You can see here in the menu the signals received and transmitted by the sensors in order to see if a sensor is still operating or not. So now no sensors connected. You see there is no signal. We will go back out into the backyard and do some measurements. The simulation means I can tell the program to just put in a value to see if the data recorder works properly and the data gets transmitted properly if I have a GPRS connection. Okay, here the V path. I have the same thing with the quick start. I see the alignment, how far the two sensors needs to be spaced from each other. So I can also have here the offset calibration. If I, for example, have installed the sensor and I close a valve and I still see a flow, then you know that the measurement is not correct. Most, let's say 99% of the cases, it's an issue of the sensor alignment. But if this is not, if you think you have done everything 100% correct, then you can put also an offset on the device. Okay, now we will go outside. So we are here on the well-known test track. Again, you know it from the previous days. You can look inside the pit, and you see here how the sensors are connected. I didn't put them on top because always air bubbles will stay on the top. Therefore, the best installation is always on the side, like shown here in our application. And I measure here on V path That means on 2 times the signal getting through the medium. And I connect now the sensors to the V1. It's the first channel. And if I would have a second sensor pair, I would need to install it here on the second connector. And the multi-IO is for additional sensors or additional power supply. Okay, now to access the main window, I always click here on back. Then you're back in the main menu and you see directly the flow. Now I don't have any flow velocity. I will leave the tablet here and I will switch on some flow. So now I put on the flow. You see flow increases. We also have some leaks there on the test track. I will also switch them on in a second. So you see it's a very immediate response of the flow velocity. It goes up. In the beginning, it always increases temperature. I don't know why that happens, but after a while, this will come down. And like I said before, if this temperature is not the water temperature, what you measure on place, and it's the difference is more than 5 to 10 degrees, then you know that something is wrong with the sensor alignment. So I will now go into the sensor alignment to show you how this looks like. If you have a good signal, this is now on a very small pipe. It's only DN80. So this type of sensor you have seen here, the clamp on, is good for DN50 until DN2500. So if the signal is green, it's a very good signal. If it's lower than 60%, this will slowly turn into yellow. If it's red, it means the signal is too low. It's not a good signal. The measurement is not done properly. Okay. I go back. Now it's already increase or decreases the temperature. That happens in the beginning when you connect the sensors. Kind of, you can say it heats up. And now it's stabilized after 30 seconds, 1 minute. So now one leak is switched on. You see only 0.01 or 2 meters per second. It's very low reading, and it's still very accurate here. You see here the curve, how it directly responds in your display.